All right, so the first two questions on our worksheet, this is the first set of notes of the quadratic review. These aren't actually quadratic. These are still linear, but this is just off of your last test, so maybe we should take a look at this. I need everyone to employ what's called the least common multiple method in order to solve this. It's really the most effective way to solve this question, but it's also a technique that I'm going to need you to use later on in math. So let's get used to it now. So LCM for 2 and 3 would be a 6. You're going to put a 6 in front of the equation, and you're going to distribute that to every single term in the equation. So let's see, 6 times x over 2 would be 3x. 6 times 5 is a plus 30. Equals 6 times x over 3 would be 2x. And then 6 times 7 would be a minus 42. And then you have a linear equation to solve. So from here, and some of you were just like really excited on your test and you made some really goofy errors, so just slow down a bit if this shows up again, but we're going to subtract 2x from both sides, of course, and then we're going to also subtract 30. And on your exam, on your summative, it said you need to leave your answer, you need to leave your answer in improper fraction form if it was a fraction. So I did have to mark you down if you didn't follow those instructions. So keep that in mind. You got to read instructions really carefully in PreCalc and give whatever answer form that they ask for. I'm going to skip 2 so we can get to the good stuff, which is our quadratics review. So today we're going to be solving quadratics using various methods, the algebraic methods in particular. So we're going to have factoring, square rooting, completing the square, quadratic formula. All of our answers today are going to be real answers, real numbers, which means the I is not going to show up today, but the I will show up in our next lesson. So right here, we are going to be asked to solve this with quadratic formula. So one of the questions on your next test is going to be, what is the quadratic formula? So, anyone have the quadratic formula memorized? This is, wait, did I skip a section? Oh, it says without the quadratic formula. Ignore me. Without the quadratic formula. Okay, come back to the quadratic formula in a minute. So what are my other methods? I could factor it. I could square root it. Does anyone think they have an idea that would be the easiest in the way this one's set up? What do you think? Sounds like you're square rooting, and that's a good choice. There's only one x in this problem, so if you isolated it, like she said, we're going to add the 5, so 3x squared equals 21, and we're not square rooting yet, right, because we're not isolated. You're going to divide both sides by 3, and you get x squared equals 7. Now we're ready to square root both sides. What we have to remember is in algebra, when you square root an equation, the answer is not just positive square root of 7, what else? Also negative square root of 7. So we shorthand that by saying plus and minus the square root of 7. If the radical reduces, if this was like the square root of 12, you have to know how to reduce that. I'm sure we'll run into that today, so we'll review that later. I think we're going to use the same method here on the next problem. There's only one component of variable in this problem. That's how I know to use the square rooting method. So we're going to start by adding the 10. So we have 3 times quantity x plus 2 squared equals 75. So the next step is the one that usually messes with kids and they mess up. So a lot of kids think they're supposed to, especially in Algebra 2, they're supposed to distribute the 3 into the x plus 2, and they make this a 3x plus 6 quantity squared. That's 1,000% illegal in math. That's not an appropriate move. You cannot distribute into x plus 2 because that's not even x plus 2. It's x plus 2 squared, which means it's x squared plus 4x plus 4. So you can't distribute into that. So instead, we're going to divide by 3. We're trying to isolate. So now we have a quantity squared. This would be a great time to square root. So we have x plus 2 equals, we know it's the positive and the negative. Square root of 25 is 5. And the goal is to solve for x. So we're going to subtract 2 from both sides. And then this would not be an acceptable set of answers for a pre-calc student. Negative 2 plus and minus 5, not good enough, guys. You can separate that into the 2 singular answers. So negative 2 plus 5 would be a 3. And negative 2 minus 5 would be a negative 7. So if your answer breaks down all the way to integers, You need to show me those answers. Okay. Or I should say rational numbers. Should feel like a good review. Comfortable stuff. We've seen this a lot in Algebra 2. All right, so here, the thing that's being squared is isolated. So as opposed to foiling this out and like doing x minus 3 times another x minus 3, it would be much smarter if we just go ahead and square root both sides. So the quantity x minus 3 is no longer squared, but I just applied a square root to a 5, so it's both positive and negative square root of 5. Square root of 5 does not break down. There's no perfect squares inside of it besides a 1. So we'd add the 3 to the other side. And this is a case where actually that is your answer. Those are your answers, I should say. There are 2 answers there. Rattle off your first answer, or a answer. An answer. 3 plus square root of 5. What's the other one? 3 minus square root of 5. Yeah, we just shorthand it that way because it's easy to write. Okay. So, I was really excited about quadratic formula for a minute. That was solving through what we call square rooting. So when you first learn that in Algebra 2, you're like, I love that method. It seems very easy and very intuitive. Like I could put up a square rooting question to an Algebra 1 student generally, and without any instruction, they would kind of feel like they're supposed to isolate x. So that's a good way for us to solve questions. Unfortunately, not every question can be solved with square rooting unless you do a little manipulation. That's what completing the square is. Completing the square is taking a quadratic that's not ready to square root and writing it in a form where you can square root it. So the idea is, first step is you take your quadratic, make sure that your a value is a 1. So this coefficient for x has to be a 1. It is a 1, so we're done with that step. Next, you put it in this form, where the x's are on one side of the equation and the constants on the opposite side. But when you rewrite it, what I need you to do is put a blank. We're going to add something right here that creates the perfect trinomial. But think about your math rules. If you magically add a blank on the left side, don't you also have to add a blank over here on the right side? So then my question is, what goes into the blank? So how'd you come up with 9? What's the formula for that? The blank is the middle term. We call it b, but it's 6 this time. You cut it in half, and then you square it. So yes, he's right. We take this, cut it in half. That's 3. 3 squared is 9. So why'd we do that? Because now you have created a perfect trinomial that factors into the squared pattern. When you have this trinomial, this factors into x plus 3 times x plus 3, which we could write as x plus 3 quantity squared. And then 7 plus 9, better known as 16. And look at that. You just set yourself up for a square rooting question. That's the purpose of completing the square. So now we go through and we square root both sides. The square root and squares will cancel, so you just have the quantity x plus 3. But remember your rules of square rooting. We just square rooted the solution for 16, so it's plus and minus 4. Okay, no pre-calc teacher on the planet's going to be happy with you if you say this is my answer, negative 3 plus and minus 4. Please give me your 2 answers. Negative 3 plus 4 is 1, and negative 3 minus 4 is negative 7. All right, number 7, same method. I need to set it up in the form for completing the square. So I check that my a value is a 1. It is. And then I make sure that the constant, the existing constant, is moved out of the way. It is. So now I'm going to leave a space so I can complete the square. And then whatever I put in that blank, I'm going to have to put into the other blank as well. All right, so remember the way we find that blank, that completed number, we call it C in algebra. You take half of the middle term, so negative 5, and then you square it. So it's negative 5 squared. It'll be positive 25. So the reason we did that is because now this trinomial is factorable. It's x minus 5 times another x minus 5, but we're going to write that as x minus 5 quantity squared. And then what's that, 36? Okay. So now we're set up beautifully for square rooting. Square root both sides. So x minus 5 is positive and negative 6. No teacher's going to be happy with me, though, if I write 5 plus and minus 6. My teacher wants both answers. So 5 plus 6 would be 11. And 5 minus 6 would be negative 1. There will be times, aka your next summative, where I say you have to utilize a certain method to solve a quadratic. So if I give you a quadratic and I say you must use completing the square, you must use completing the square. I'm very well aware that you can use multiple methods on problems, but your job is to show me that you know how to utilize all the methods. Sometimes we get kids who are like, I solve everything with quadratic formula. That's possible, but that's not what I'm interested in. I want to know if you know all the methods. Okay. Oh boy. This next one, the good news is the a value is a 1, so that's good. The bad news is the constant's not moved over, so we got a little bit of work there. And then we have some other bad news. Does anyone remember what happens in this problem, why it's a little more exciting than our previous two? It's going to be a fraction, yeah. We're going to do fraction instead of decimal, but yeah. Okay, so think about this, guys. If you took a fraction, so in this case, 13 halves, and you squared it, that's just squaring the numerator and the denominator, so it's 169 over 4. So I don't want you to overthink the factoring pattern. The factoring pattern has its own pattern. It's always x and then plus half of your b term. So x and then this thing cut in half was plus 13 over 2. Sometimes the Algebra 2 students were like, I don't like factoring. But this kind of factoring was easy. Always the same. Okay, 4 plus 169 over 4, if you're doing this in your brain, kudos to you. You have to get common denominators. So that'd be 16 fourths over 16 fourths plus 169 fourths. Otherwise, you can just type 4 plus 169 fourths. I need you to math enter that back, though. So 185 fourths or something? 185 fourths? Okay. So adding these together, we get 185 over 4. And I know the fractions are scary, but they work out kind of nice in these. If we square root both sides now, I know this side is just going to be x plus 13 halves. And I know it's plus and minus, both positive and negative solution. When you square root a fraction, you're square rooting the numerator and the denominator separately. So you're taking the square root of 185 over the square root of 4. So you might have to play around with the 185 for a minute, but I don't think 185 reduces at all. It's not divisible by 9 or 4 or 16 or anything. So I'm going to leave that as the square root of 185. However, I can totally do the square root of 4. That's a 2. So then final step, I would take this 13 halves and subtract it over to the other side. So this is going to look kind of messy, but it's negative 13 halves plus and minus the square root of 185 halves. Notice the 2 is not in the radical at all. Anyone know an alternative way to write that answer, though? If they have common denominators like that, can I just smush this into one fraction and write negative 13 plus and minus square root of 185 over 2? That should give you some memory of what we call quadratic formula. That's what answers typically looked like in quadratic formula when they were a little funky. This is a case where it's a little funky. So I don't care which version of the answer you provide me on this question. I just want you to be flexible enough to understand that they're the same thing. All right, so that's completing the square. Factoring. That purple sheet you all did for homework, that was getting you ready for factoring. So y'all should be wizards again. No common factor, so moving down, this is a trinomial, first, outer, inner, last. So this is a pretty easy one for us, guys. What times what is x squared? Obviously, that's x and x. Something times something is negative 9, and then your outside plus inside arches have to add up to negative 8. So after you kind of mess around with this problem for a while, you end up with negative 9 and a positive 1. Those are your factors. But because this original problem was an equation that wanted me to solve my factors, you are not done. The reason this method works is because if you have two numbers that are multiplied together, like a times b equals 0, what do you know has to be true about a and or b? If you multiply two things together and the answer comes out to 0, one of them has to be 0. So this is what we call it's not the official term or anything, but take your turn being 0. So either x minus 9 is 0, or x plus 1 is 0. So now you can take it further and actually give me the single answers for x. So x is either 9, or x is negative 1. We have to have really refined skills on this stuff, which I know you're like, oh, I'm really good at these. I did these a ton in Algebra 2. Wonderful. We're going to use this skill later on in the course for some really nasty questions. So you have to be very well versed in, like, when is it acceptable to set them equal to 0, and how do you solve them, and why are you doing it? All right, this next one, this is an equation, and I notice every single term in the equation is divisible by a common factor. Because it's an equation, instead of just factoring out the 2, you can actually come through and divide by 2. The only reason you can do that is because it's not going to affect the balance of your equation. 2 doesn't change the balance when it's an equation. So x squared plus 5x minus 14 equals 0. And that's a pretty nice, easy factoring question for us. It's going to be x and x, and then I need my back numbers to multiply to negative 14, but I need my outside, inside arches to add up to 5, so after a little bit of thinking, you guys should settle on a plus 7 and a minus 2. Now again, those are just my factors. So because they want me to solve my quadratic, I need to say, okay, well either this factor is 0 or this factor is 0. So x could be negative 7 or x could be 2. When we get to something like number 11, where I'm hoping at this point you guys start recognizing that that's a special binomial. It's one of our patterns. X squared and 49 are both perfect squares. So this is that nice pattern where they look almost identical except one's a plus and one's a minus. So the difference of two squares pattern works out where you take the square root of each term and then you make one a positive 7 and the other one will be a negative 7. Because it said you must solve through factoring, if this was a test question, I need you to solve it through factoring. I know there's other methods, but that's what they wanted. So take your turn equaling 0, so x plus 7 is 0, or x minus 7 is 0, which means x could be negative 7, and x could be positive 7. Which answer is right? They're both right. If you think about this, x squared equals 49. If you were to look at a picture of this graph, x squared is like our parent function of a quadratic, and then the function 49 is just a line, like up here at 49. So that red line would cross the parabola at negative 7 for x and positive 7 for x. So that's what we're solving. Okay, factoring only works when you are in factoring form, which means standard form. So this guy here, not in standard form, so you have to manipulate it first where you add the 8 over. So, man, these have been kind of nice. Looks like they're going to step up in a minute, though. X and x, whoops. And then multiplies to positive 8, adds up to negative 6. So that'd be what, a negative 4 and a negative 2? But again, those are just the factors, guys, so you do need to give me the solutions. I don't mind if you skip writing out this algebra step, because I think you guys can solve a 1 or 2 step linear equation in your head. This will provide you x equals 4 as a solution, and this is x equals 2 as a solution. Okay, it's a little more exciting here on number 13. So, not quite in the form that we need. 2x squared minus x minus 3 equals 0 is standard form once you get it in that form. The coefficient being a 2 instead of a 1 creates a little more excitement in your factoring. Now, I didn't make a big deal about this yet. If you employ what's called slide and divide, I want you to step away from slide and divide from here on out, okay? It's going to slow you down to the point, and it won't work when you have trigonometric factoring. So, no more slide and divide. Erase it. You just have to learn how to reverse FOIL, which is what factoring is. So, the first two terms have to multiply together to give you 2x squared. Since it's a prime number, the only option for that would be 2x and 1x. Now, my last two numbers have to multiply to negative 3. So, 3 is prime. So it has to be 3 and 1. But the placement of the 3 and the 1 makes a difference, right? If I were to put a 3 back here, that's going to create a 6 on this arch. And when I look at my middle number, I'm supposed to be adding up to a negative 1. So I don't think that's the right direction. So I should place a 3 here and a 1 here. And now I got to think about my signs. One's positive and one's negative. Well, if you make the 3 negative and the 1 positive, this is why it works out. Look, this is a positive 2x plus negative 3x, and those would add up to negative 1x, which is what you need in the middle. So now that I've confirmed I have the right factors, I got to go back and take my factors and set them equal to 0 like we did before. So 2x minus 3 could be 0, and x plus 1 equals 0. All right, so we're solving this. We're going to add the 3 over, of course, and divide by 2, so x equals 3/2. And here we just subtract the 1. Should feel really reviewy, right? We did lots of factoring. Even in regular algebra 2, we did tons of factoring, so can't imagine how much you did in honors. Okay, 9, 3, 30. Is there a common factor there? 3. Can't they all be divided by 3? So it's always a good idea in an equation that if you have a common numerical factor, you divide it out of there. It makes your number smaller. So my new problem is 3x squared. Where are we at? Minus x minus 10. So this is the kind of factoring where it might take me a couple guesses and checks, but I'll get there. We learned last year in Algebra 2 that even though sometimes it's essentially a guess, it is an educated guess. Like, I know what not to do when I'm factoring because I've learned through many experiences of what doesn't work. So let's start with the first term's multiplying to 3x squared. Well, it has to be 3x and 1x because that's prime. And then when I think about the negative 10 is one of those numbers that has multiple factors. So like, yes, 10 and 1 would be an option, so is 5 and 2. And your math teacher should have given you some insight. Like, we generally don't pick the numbers that are really extreme away from each other, like 10 and 1, because those provide really gigantic arches when you do that. I'm not saying never, just generally we don't. The only exception to that would be maybe I want a really big number in the middle. Like if my middle number was 29, then maybe I would want to do that, but it's not. So instead of picking 10 and 1, let's just agree to go with the 5 and 2. I don't know where to put the 5 and 2, so let me think about that for a minute. If I put a 5 here, that's going to be 15. Way too big in the middle. So let's put a 5 here, and a 2 here, making a 6 and a 5. There we go, that works, because what if you make the 6 negative by throwing a negative right there, and a positive right there? So you got to confirm that you have the right factors before you solve. So take your factor and solve it, and take your factor and solve it. All right, so like this one, we're going to subtract 5 and divide by 3. I'm going to skip those steps, so it'll be a negative 5/3, and that'll be a 2. Okay. So, quadratic formula. It is awesome, and it's actually a derivation of completing the square. For funsies one day, we can actually derive that formula if you want. Today's not the day, though. We have a quadratic in what we call standard form. So ax squared plus bx plus c equals 0. And then if you can identify your coefficients, which are a, b, and c, you can place them into a simplified version of a solution for a quadratic, which is that. And the cool thing about quadratic formula is it always works. It's not always user-friendly, it's not always pretty, but it always works no matter what your quadratic is. So if you're given the luxury of choosing a method to solve a quadratic, most kids do not choose quadratic formula, but if you're stuck, it is always a backup plan of what will work. The catch is, here in PreCalc, you have to know quadratic formula. In Algebra 2, they may have given that to you, but you no longer will be given this formula. So it's the opposite of the b plus and minus the square root of b squared minus 4ac, all of that divided by 2a. So when I look at number 15, it is in standard form. The coefficient here in front of the x squared is a, so a is 1, b is negative 4, and c is the constant, so it's positive 1. All right, here we go. X equals, the opposite of the b term would be positive 4, plus and minus, big square root. Don't simplify anything right now, just place the numbers where they belong, with the exception of this first number. I always suggest to my kids when they go and square b, just write down what b squared is, because sometimes we get kind of calculator happy and we type it wrong. What's negative 4 squared? Positive 16. So I just write down positive 16 so I don't have to worry about parentheses later, on that part at least. Minus 4 times a, which is 1. Remember, a was 1. Times c, which is also 1. Now, big mistake I see even from pre-calc kids. This fraction bar, which I believe has a name, it's called vinculum, fun fact, has to be underneath everything in the numerator, not just the radical. And then you're dividing by double the a value, which was double 1. All right, now it's time to simplify. I want you to do this in stages, though, because sometimes this doesn't work out pretty. 16 minus 4 times 1 times 1. Well, that's 16 minus 4, better known as 12. The other thing I'd like you to simplify next would be the denominator, which is just a 2. But that's not an acceptable answer for pre-calc or algebra 2 even, because the square root of 12 reduces. Think about square root of 12. What perfect square is a factor of 12? 4. Yeah, that's really like the square root of 4 times the square root of 3. So we're going to rewrite square root of 12 as 2 square roots of 3 over 2. And what do you think about me leaving my answers like that? Still no. Can you tell me why? These coefficients can all be divided by 2. So you need to take it that far and say it is 2 plus and minus. You can write a 1 if you want, but it's 2 plus and minus square root of 3. 3, hello, 3. So my answers, after all that work, 2 plus square root of 3 and 2 minus square root of 3. Whew. So it's a little cumbersome, not always the greatest formula to use. My personal favorite way to solve quadratics is completing the square. I've always liked it. I just think it's neat. Quadratic formula is cool because it always works, but it's a little awkward. Unfortunately, you guys don't have the luxury of knowing or of deciding on my test what formula to use. So if I say you must solve this with quadratic formula, I mean it. All right, 2x squared minus 6x minus 5. At first I was kind of excited because I thought I could divide by a 2. I can't. The 5 messed that up. So we're just ready to go into quadratic formula. So our a is 2. Our b is negative 6. And our c is negative 5. I'm going to have to put number 17 on another piece of, like, another slide. So I'm going to use, like, all this space, and I'm going to come back and do 17 later. If you don't have room, we'll figure it out. I know it's pretty tight on space. All right, so x equals the opposite of b. So the opposite of this b term would be a positive 6. Plus and minus square root of. Instead of writing negative 6 squared, I'm just going to write down positive 36. Minus 4 times a is 2 times c is negative 5. And then all of that math is being divided by 2 times a. So in our case, that'd be 2 times 2. Okay, here we go. X equals 6 plus and minus. I do need to simplify what we call the discriminant on my calculator or my brain. That's 36. That'll be, what, plus 40, so 76? Yeah? Okay. I don't know why I made that radical so big, or square root sign so big. Divided by 4? Okay, pretty sure 76 reduces. I know it's divisible by 4. What is 76 divided by 4? Was it? Oh, that's the one. 19 is not reducible, so I know I can stop with my reducing. 76 is, thank you, is square root of 4 times square root of 19. So we're going to rewrite that as 6 plus and minus 2 square roots of 19. Still, all of that's being divided by a 4. So how do you feel about me leaving my answer like that? Not good enough for pre-calc. Look at all your coefficients. 6, 2, and 4. Are all those divisible by a common factor? Yes, they're all divisible by 2. So you need to cut all of these by a 2. This is all one number, this red thing I wrote down. So the 2 and then the square root of 19 are it. 2 is the coefficient. So final answers are 3 plus and minus 1 square root of 19. All of that over 2. So 3 plus square root of 19 over 2 and 3 minus square root of 19 over 2. Woohoo! Ugly. Huh. This is one of our favorite memes in the math department. You know how many times I've caught a kid doing this? And then the argument ensues. They're like, what do you mean I can't cancel the x squareds? Well, guys, this is a number. And like that's a totally different number. So when the kid says, I'm going to cancel the x squareds, my argument is there's not an x squared in that problem. There's an x squared plus 2x plus 1. There's an x squared plus 3, but there's not just a singular x squared as a factor. So the reason we brought this up is because, you don't have to write this down, we get this a lot. Say this was my work. Okay? I got to this step. And then some lovely child comes through and goes, no, no, you need to keep going. This is a 1 over a 2. Why is that mathematically unacceptable? They just like completely ignored that term. It's like when you don't distribute all the way. Like you have to do it to every term. If you're going to divide by 2 everywhere, or divide by 5 everywhere in this case, you can only do it if every single term can be divided by 5. So what that kid did, I don't ever want to see you guys doing that. Which probably means there's a question coming up that happens. All right. A little bit of vocab for you. The discriminant part of the quadratic formula, the stuff that's underneath the square root symbol, just the b squared minus 4ac part, that tells you what kind of answers you're going to get. So think about it this way, guys. So you do quadratic formula. You have like 4 plus and minus the square root of, what if you come out to the number 0 right here? What is the square root of 0? 0. So if I do 4 plus 0, and then later on I do 4 minus 0, did I get 2 different answers? Not at all. I got just one answer, just showed up the same twice. So when your discriminant is 0, that means you only have one real solution. We'll write this down on your notes in a second. But if that same situation occurs, but this time underneath the radical, you have some number, some positive number. Okay? I don't care if it's a pretty number or an ugly number, like square root of 6 or the square root of 121. Either way, you're going to get 4 plus something and 4 minus something. You just got 2 real answers. But what if we go through all our math and I end up with something like -3? What happens when you square root a negative number? Do you remember this from algebra? You end up with an imaginary solution or complex solution with an I in it. So it's going to be like 4 plus something I and 4 minus something I. So you still got 2 different answers, but they are no longer real solutions. You get 2 imaginary solutions. So that's how our discriminant can help us figure out what kind of solutions we have. You don't have to go through all a quadratic formula. All you need to do is to figure out if the discriminant is a positive number, you're going to get 2 real solutions. So what do we have here? B squared, sorry, C. Okay, so if it is a negative value, then the solution is going to be 2 imaginary solutions. So somewhere on your paper, you need to highlight or write down what we just had on this slide. So if the discriminant is 0, you have 1 real solution. If the discriminant is positive, you have 2 real solutions, and if the discriminant is something negative, you have 2 imaginary solutions. Very loud video. Is that driver's ed? We're going to have a chat, Heinrich. I'm pretty sure your driver's ed video doesn't have to be blaring through the brick wall. Goodness. I know, and I know those videos are stupid. They don't have to be that loud. Come on. He already took my parking spot. I'm still salty about that. I have to edit that part out. All right. Okay. Are we at the end of your notes? So we have more examples? Okay, we'll come back and do the examples another day. So can y'all look at worksheet 2? I'm going to stop the video, and I'm going to have to go back and edit all that out.